So, now we begin the topic of what are called imaginary numbers. This will eventually lead to a larger topic of complex numbers. But in order to get there, we kind of have to develop the simplicity of the imaginary number. So, for example, equations such as x squared plus 1 equals 0 have no real numbered solution. So, in algebra 1, if you were to try to solve that, you might subtract 1 on both sides and get x squared is equal to negative 1. And then you would try to do the square root on both sides. But whenever you type that in a calculator, you would end up having an error message. So that's what we mean by no real solutions. No number in the real number system is going to give us an answer to this. So, mathematicians came up with a solution, which is the imaginary unit. We call this imaginary unit I, and I is defined as the value that I is just simply defined as the square root of negative 1. It's the solution to this problem. We simplify the square root of x squared. Well, it would become x is equal to I, simply I. And it ends up being super useful. I mean, it sounds weird, imaginary numbers, but they have so many real world applications that it's almost hard to even list them all. So let's start with some of these problems. Evaluate 3i squared and negative 9i squared. Are 3i and negative 9i imaginary numbers? And let's just start with that part. So 3i squared. Well, we remember the distribution rule for exponents. This is 3 to the first power. And we can think of this as I to the first power. So we have to distribute, meaning we multiply the exponents. So 1 times 2 is 2. We get 3 to second power. And we get I to the second power for the same reason. We know that 3 squared is 9. And then I, we understand, is the square root of negative 1. But remember, when we have a square root being squared, the same rule still applies. It doesn't matter if there's a negative 1 in there. It still cancels out. So we have 9 times negative 1, which is simply negative 9. Okay. How about the next part, which says negative 9i squared? Again, we're going to distribute the exponent. So this becomes negative 9 squared times I, which we know is the square root of negative 1 squared. Negative 9 squared is a positive 81. And I, where the square root of negative 1 squared is negative 1. Which means that this whole thing is equal to negative 81. So it's asking, are 3i and negative 9i imaginary numbers? Well, yes, because when we square it, the square is a negative. We have 2 negative values after we square them. Which means that, for instance, if we were to kind of work backwards and say like, oh, I have some x that's the square root of -9. I mean, it's the reverse process of what we just did. We could eventually find out that that is the same thing as 3i. And that if we have that x is equal to the square root of -81, we could find out that that is the -9i. So yes, they are imaginary numbers. So part B asks us, suppose a is a real number, can the square of ai be positive? Is ai an imaginary number? Okay. So let's take a times I, square it, and hopefully it makes sense that we get a squared times I squared, which becomes a squared times the square root of -1 squared, which is the same thing as a squared times -1, which is -a squared. Now, a is a real number. Its square is not negative. We've defined a as a real number. So if we were to, like, any value that we could plug in for a has to be positive since it's not defined as imaginary. But -a squared cannot be positive because they have that negative in the front. So we have this situation where, like, all right, we have that as an equation, like x is equal to negative I should say the square root of -a squared. Whenever we have that negative inside of the square root, it causes us to get an imaginary value, because you can, like, think of it as we broke it up before. This would become, well, that negative in the front is the same thing as -1, and we have times a squared. Separate the two, we have -1 times square root of a squared. Well, -1 we define as I times the square root of a squared, which is a. And just like normally we flip them to keep the real number in the front, so that x is a times I, an imaginary value. So whenever we have this situation where if we take the square root and it has a negative in it, we have that it is an imaginary value. Or that whenever we square a number, it becomes negative. That is also a sign that we have an imaginary number. So we say that if a is a real number, then a times I is an imaginary number. And to lead us into the next problem, I is the solution to x squared equals -1. However, this equation is a quadratic, and most quadratics that have been studied in the past have two solutions. So does x squared equals -1 have two solutions? That's what we will be exploring in the next problem.